Welcome to ICE training for exercise version 7. My name is Craig Slagle and I'll be explaining some of the key concepts in ICE over the next few sessions. ICE stands for Interactive Creative Environment. It's a node-based system for creating and prototyping tools and effects in XSci. It contains a library of nodes that we can see here, and these nodes can be linked together visually to create advanced effects and deformers and systems and tools, anything from a standard deformer to a crowd system. You start with a node with an ICE tree, and the ICE tree can be applied to any object, and it can be applied to geometry such as a polygon object, or to a point cloud, and a point cloud can be used to create a particle system. ICE is actually point-based. That means it will be used to manipulate and change points in the object, or in a point cloud it can be used to create or remove points to create particle systems. The ICE trees can also be applied using scripts. They can be packaged together into what's called a compound, and they're used as a very artist-friendly tool, just like any tool you'd have inside XSI, apart from these are custom tools that anyone can use and create and edit. So if we want to start by making an ICE effect, let's start with a primitive. We'll take a primitive polygon mesh sphere. I just change the subdivision so we have a bit more detail. I will go ahead and make a single view here and change from camera to user just so we can see more in this one window. There's no ICE tree on here. If we hit the refresh button, you'll see no ICE tree. And currently we're looking at the ICE layout. Your default layout is on the View, Layout, Default. Do that again. Default. And you can see our default layout here. The ICE layout is on the View, Layout, ICE. You can also just open up, if you want, under General, an ICE tree. That's what you're seeing at the bottom here. Or the ICE Runtime Messenger, and this allows you to help define or modify performance. You can see how much processors used per node. So with our object selected, we can create an ICE tree. ICE trees can be created from the ICE tree create menu. You can create an ICE tree that happens exactly when you change values in here. You'll see the value change in real time in the screen. Similar to ICE tree is per frame, so any change will be per frame. As you go forward in time, those changes will be additional. So if a point moves point one frame, it will stay there. The next frame it will move another point one. So this can be used quite often for effects such as maybe an ocean style effect, or you could use it for, of course, particle simulation is most common. If you want to create a particle simulation, you can also go create emit from particles from the simulate menu. And there is also under View Toolbars an ICE toolbar that has a couple of buttons, one to create an empty point cloud, or also emit from selection. A point cloud can also be created from a primitive point cloud, empty. So lots of options to work with ICE. ICE also exists in the render tree, and we'll look at that a little bit later on. So we have our sphere created. We're going to apply a standard ICE tree, create ICE tree. Now you'll notice the sphere has an ICE tree on it. In the properties, here's a small Explorer view. You can see there's an ICE tree under modeling. If we went to the Explorer, by hitting 8, you'll see under sphere, under geometry, under modeling, there's an ICE tree. So once you have an ICE tree, we can now start dragging in nodes. The first node you usually start with is a data node. And there's different kinds of nodes you can see here. There's both tools and tasks. Tasks are a series of nodes put together in what's called a compound to perform more complicated tasks. Tools are mostly simple nodes, and we want to start with a data node. So we can search here, we have all nodes here, we can see data access. And then we can find different data nodes. You can also type in the name of a node if you know it. If it's a window here, like get D, and you'll see get data. You can just drag and drop nodes in to get the node. You'll see this node's currently red. Red means either there's an error or it hasn't been hooked up yet. it hasn't been hooked up yet. You can double click on the node to get the node properties, and then pick a property to apply the node to, or get the data from a scene element. In this case, we hit the Explorer, and we see the sphere, polygon mesh, and we can see all the properties on this object we can look at. So here we can see the age, area. Some of these are per object properties. You can also go all the way down and get the kinematics. You can only read kinematics, not set them unless you turn on the unsupported attribute. So let's go down to point position. There's polygon position and point position. That's every point position on the object. When we got that, you just turn to a blue color, showing it's a valid node, and it has a couple of outputs. Here is a yellow output. Yellow means it's a vector output, and green, I believe, means a string output. Let's now get a set data. We can go back to our data nodes if we want. We can get all nodes here. We can clear, and you'll see everything clears. We can see a set data down the bottom. And then we can decide we want to set the point position. So we go Explore again, Sphere, Polygon Mesh, and find point position. And then we can just link these together. So if we link the execute into the ice tree, everything would disappear. Hasn't really disappeared. What's happened is, if I hit T, you'll see a point. It may be hard to see, but there's a point right in the middle of the screen there. If I turn the grid off, we can see a little blue dot right there. Now we have that point position, we can feed the ones we got in here first of all, and the object comes back. So now we've got the point positions, and we've set the point positions. That's not a very interesting ice tree because it doesn't really do anything. So this is when you use math nodes to affect the different properties you've got, or setting. So let's find a math property. Here's math, and there's an add. Nice simple add. We just drag and drop. Now we can drag and drop these in here, and then the result in there. That's one way of doing it. Or when you create or drag in a new ice node, you can actually drag and drop it onto the line. You'll see the line changes color slightly, a little gradient. When we let go, it'll link it in for you to save you maybe a few seconds. Now if we start increasing the Y, we'll see the object will move up and down. It's actually moving all the points up and down in this case. So that's the add node. It's still not the most interesting deformer, it's just the one that moves our object around. You could use a normal, get the normal, add the normal, and then you could create a push style deformer. In this case we're going to use a randomized value. So we're just going to, actually we'll do a turbolize value. So we can type turbolize, T-U-R, and we can see turbolize object, and we can see here turbolize around value. And then all you do is you can bring in the base value here. We don't need this add node anywhere. Bring the value back out in here. And we delete this node by clicking, hitting delete or backspace. We're a little bit too much turbulence there, so we can bring turbulence scale down. And we can bring the variance down. At the moment it's 0.1. We can bring this down, or 1, we can bring it down to 0.2. Maybe that's too little. Let's adjust the scale a bit more here. Let's play around with that. Maybe 0.4. And there we are, a little turbulence. Now it's not the most interesting. You can turn on animated. Right now if I hit play, it just stays in that position. If I turn animated on, it will actually animate it over the frames, and we now have our swirly, kind of pulsating, turbolized sphere. And there it goes. You can adjust the animation speed to have it animate faster or slower as you want to work with it. But just hit play again, and here's a simple ice effect and you can see it's running fast. It has a turbolize. If this turbolize is a task, you can see here there's an E here, and the E means you can edit this compound and look inside it. And you can see there's lots of interesting nodes linked inside here. We can also go in and explode or recreate or change things inside if we want to. So we've now, just go through this one more time, we've got the point position of the sphere, we've turbolized the values, and then we've set the point position back to the ice tree. Let's just change a couple of things in here before we finish off this introduction. We're going to change it from sphere to self. And self means it's looking at its own, the object it's currently on. And you really want to use self whenever you can, because using self means it's no longer object specific, and then we can apply this to another object very easily. So we just type in self in here, and there we are. So this is self. Now we can apply this to any object. We can make this into a simple compound. We'll talk about compounds in detail in a second, but I can pick all these points here, and I can go right mouse button somewhere here. Yeah, create compound. It puts it all into a little compound. We can later on we'll look at the compound properties, but just for the moment we'll just go right mouse button, compound properties, and just change its name. Turbolize object. Probably spelled that wrong. And then we have this compound we've just created. We can export that out to reuse it, and you can make custom compounds by just exporting them, or we can just copy and paste it. We're just going to create another object for the moment, primitive polygon mesh cube. We'll give it a lot more subdivisions. There's our subdivided cube. We'll just take this one here, copy it, Control C, and I'm just going to go to the cube, create ice tree, Control V, there's my turbolized object, and we'll just link it in. And we'll just move that object to the sides here, and let's go shaded because it'll look more interesting. And we have our two objects now that have been turbolized, and we've created a simple tool inside ice that creates some somewhat interesting effect quickly and simply. And that gives you an overview of ice. So we're working with points, we're getting points, we're editing points. We created a simple compound. We can go inside and change things, and this is really a quick overview of ice. Now we're going to move ahead and create a lot more advanced and more interesting effects.